Hello everyone, welcome to Code Chef. Myself Jwala Charas and today we are going to solve a problem which came into starters 204. The name of the problem is drawing chances and the problem code is draw ch. The difficulty rating of the problem is cakewalk and the prerequisite is ad hoc. Let's start with reading the problem statement over here. So guys, problem says Alice and Bob are playing a tournament which consists of n matches. Right now they have completed m where m lies from 1 to n matches already. So and you have the results from those matches. We are given a binary string s of length m, where s of I equal to 1 means that Alice won the ith match and s of I equal to 0 if Bob won the ith match. At the end, whoever has won more matches wins the tournament. However, if both of them wins equal number of matches, the tournament ends in a tie instead. Given the matches that have already been played, is it still possible for the tournament to end in a tie? Print yes if it is possible and no otherwise. Input format. The first line of input will contain a single integer t denoting the number of test cases. Each test case consists of multiple lines of input. The first line of each test case contains two integers n and m, the number of total matches to play and matches already played. The second line contains a binary string s output format for each test case. Output on a new line yes if it is still possible to have a draw and no otherwise. Constraint for t lies from 1 to 100, for m and n lies from 1 to 100, where s of I belongs to 0, comma 1. So guys, now let's understand the sample test question in the test cases more precisely over here. So guys, this question is pretty much straightforward to understand. It says Alice and Bob are playing some tournament which consists of n matches. And right now they have completed m, where m lies from 1 to n matches already, and you have the results from those matches. You are given a binary string s of length m, where s of I equal to 1 means that Alice won the ith match and S of I equal to 0 if Bob won the ith match. At the end, whoever has won more matches wins the tournament. However, if both of them wins equal number of matches, the tournament's in a tie, right? So we have to, given the matches in this binary string, we have to check whether after these played matches, that is m played matches, is it still possible to make a tie in this? So if it is possible, we will print yes. In other case, I will simply print no. Let's take the first test case, guys. We have got n m, which is 2 and the string is 10. First match is won by Alice, second by Bob. So is it possible or not? So yeah, so the tournament has already completed all the matches, and if you will see, there were total two matches, and two of them are already played, and one is win by Alice and one is win by Bob. So equal number of, so it is a tie. So yes, it is possible, right? So output is simply yes. So you can see that, guys. I have got the output for the test case. Yes. Okay. Now let's take one more test case, which is 4 3. It is NM, and the string is 1 1 1. Okay. So in total, four matches, and three are already played, right? And all the three are won by Alice, and only one match is left for play. So whoever will, let's say Bob also wins. So still, it cannot be equal to Alice wins, right? So there can't be tie possible in this case. So output for the test case, no. So guys, I think the test cases are pretty much clear. Now let's move for the simple solution. So let A denote the number of matches that Alice has already won, and B denote the number of matches Bob has already won. These can be found by counting the number of zeros and ones in the binary string as there are n minus m matches remaining, and each of them can be used to increase either A or B by exactly one. Our goal is to have A equal to B in the end. First, note that if n is odd, it's definitely impossible for the final result to be a tie. After all n matches, one player will have an odd number of wins, another an even number, so they cannot be equal. So in this case, we can immediately answer no. Next, consider the case where n is even. We want Alice and Bob to have an equal number of wins in the end, which means they must both end up with exactly n by 2 wins. So in particular, if either Alice or Bob have greater than n by 2 wins, it's surely impossible to make them have exactly n by 2 wins in the end, making the answer no immediately. That leaves the case where n is even and Alice and Bob both have lesser than equal to n by 2 wins initially. In this case, it is indeed possible to make them both reach n by 2, since we can just make Alice win n by 2 minus a remaining matches and Bob win the rest, which will equal n by 2 minus b. So guys, I think the solution is pretty much clear. Now let's move toward the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as nm and as well as my string. I initialize Alice count for 0 and Bob count of all ones. Basically their wins. Okay. And over here I'm doing my operation, and the last I'm simply print yes and no according to the condition. And as you can see that, guys, I have got my C++ code, right? Now let's move toward the Python code. So guys, this is my Python code similar. I took the input for all the test cases as well as my string nm also, and I am counting the number of Alice and Bob wins basically by 0 and 1. I am checking the condition accordingly, printing yes and no. And as you can see that guys, I have got my Python code as well as right. So guys, I think the solution, the code and the approach was pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.